this question is related to equilibrium. Each diagram shows three forces on the beam. In which situation it is possible for a three forces shown to be in equilibrium. First thing, when we want the object to be in equilibrium, there should be no resultant moment and there should be no resultant force. So pivot is not given to us. You can consider center also as a pivot. Let's say, because I can consider, but I have to consider the same point as a pivot. Let's say I'm considering center as a pivot. So if I consider first thing, upward force should be equal to downward force, means length of these two arrows must be equal to length of upward arrow, which looks same. So there is no resultant force. But what about the turning effect? These two forces are causing the same turning effect and there is no force to oppose the turning effect. So means this cannot be in equilibrium. Now, what about B? If I consider center as a pivot, first thing, there should be no resultant force and there should be no resultant turning effect. When I apply, okay, this force cancel out this one, but still there is an upward force. Because there is an upward force, so why A is wrong? Because A, there is a turning effect. Rotation is there. If I consider this as a point of rotation, this force will not cause any turning effect. This is acting downward to cause a clockwise turning effect. This force is also acting downward to cause a clockwise turning effect. So as a result of these two forces, both forces cause a clockwise turning effect. That is why the object will not be in equilibrium. To be in equilibrium, no resultant force, no resultant turning effect. So there is no resultant force, but there is a turning effect because of these two forces acting in the same direction and both are the same side of a pivot. So there is no force which opposes the turning effect of these two. What about B? This force cancel out this one. But if you see, there is a vertical upward force is there. So if there is a vertical upward force, what will happen? There is a resultant force. So means this will not be in equilibrium. To be in equilibrium, no resultant force, no resultant turning effect. What about C? When we take a pivot, if you compare the turning effect, this is causing an anti-clockwise turning effect. This force will also cause an anti-clockwise turning effect. This force will also cause an anti-clockwise turning effect. So all these forces are causing a turning effect in the same direction. So if they're causing a turning effect in the same direction, means there is a resultant turning effect or a moment. So this cannot be in equilibrium. When we check D, first thing, no resultant force. How no resultant force? The total upward force must be equal to total downward force. So the length of the two arrows which are pointing up equals to the downward arrow. So there is no resultant force. Now what about the turning effect? When we compare the turning effect of these two, so with that, if the center we are taking a pivot, so which direction this will try to cause a turning effect? So there is no resultant force on this one. And what about the moment, the turning if? So first thing we check, the total upward force equals to total downward force. So there is no resultant force on this one. What about this one? The two forces are cancelling out the effect of each other. And there's a vertical upward force, so there is a resultant force. What about this one? Two forces are there and acting in opposite direction, but still there's one force acting. So this will also cause a rotation, turning effect. Moment of D, when we consider the clockwise moment is equals to anti-clockwise turning effect, here we take a pivot, the center of the rotation. These two forces are not acting in the same direction. If you these two forces are not acting in the same distance from the pivot. Like here, see this force and this force. So these two forces, when I take a center, this is a center. So which direction? This causes a turning effect. This will cause a turning effect in a clockwise. Which direction this force is causing a turning effect? This will also try to cause a clockwise turning effect. And which direction this third force is acting, because it is further from the pivot as it is closer to the end, this will try to cause an anti-clockwise turning effect. So these two clockwise turning effect may balance with this anti-clockwise turning effect, so it can be in equilibrium. The downward force, yeah, this downward force is greater, but it is closer to the pivot. So its turning effect will be, so the turning effect of this force, the clockwise plus clockwise, is equals to this anti-clockwise turning effect. Is it clear about D? Okay.